Okay, moving on. The converse is also true. The higher reduction potential means more likely to be reduced. Okay, and you can expand that logically. The lower a reduction potential is the more likely that that half cell will be oxidized. All right, if you connect two half cells, the higher reduction potential is the one that's going to be reduced. The lower reduction potential is going to be the one that's oxidized. But we already know that based on SOA above an SRA, which one gets reduced, which one gets oxidized. All right, here's where it gets good. The difference in the reduction potential of two half cells, if you connect them, is equal to the maximum cell potential, which is voltage, when they create a cell. So I'm going to talk about our copper zinc cell again. They each have a unique reduction potential. Okay, so let's find copper. It's up here. It's got a reduction potential of 0.34 volts. Zinc's down here, negative 0.76. Okay, so copper has a harder pull on electrons than zinc, which means it's going to steal those electrons through the wire. The voltage between these two electrodes, the maximum you can get is when you subtract these two values. So let's do that. I've set up an example here. Calculate the maximum cell potential for a copper zinc cell. The formula is pretty ugly, but it's simple once I explain what every term means. This is just standard cell potential. I don't know why chemistry is using an E. I would use a V, but I'm going to follow the book. All right. This just means reduction potential of the cathode subtract the reduction potential of the anode. All right. So we looked that up already. The copper was 0.34. The zinc was negative 0.76. If you subtract those, you'll get 1.10 volts. Okay, in my really rudimentary cell with an old ugly piece of zinc connected to the copper, I was getting just under 1 volt. Okay, so again, this is the maximum value we could get. I could make some adjustments. It helps if there's more surface area in the electrolyte to pump up the voltage of my cell, but theoretically, I could never get it above 1.10 volts. Okay, which isn't bad. A AA battery is 1.5 volts, but you couldn't get that from copper and zinc. You would need to use other metals, which of course they do.